G'day everyone, my name's Mackenzie and this is the SIGIR 2022 short paper poster presentation for the paper Fast to Learn Sparse Retrieval with Guided Traversal. And this was work done with Antonio Mallia, Torsten Suel and Nicola Tonellotto. So to start off with, we'll quickly talk about learned models. So basically inverted indexes, which we've been working on for 40 or so years. They support fast search over large-scale text collections. And usually if we want to rank documents with inverted indexes, we take statistics out of the index like term frequency and document length, and we might compute scores according to some traditional model like BM25, for example. But recently there's been some work on learned models which can actually learn the term document impacts for each term document pair, and you can store those in inverted indexes instead of term frequencies and use those to rank documents. Now, these learned sparse models, they're much slower than traditional models like BM25, but they're also much more effective. And so the reason they're slower is because of unfavorable impact distributions. And so basically, in a nutshell, efficient inverted index based traversal, it relies on term upper bound estimates. So essentially the highest score that you can get for a single term, for each term in the index. And what that allows you to do is quickly make an estimate of the maximum possible score a document might have, and then you can skip documents which would be unable to make it into the final results set. So if you look at this figure, you see that BM25 on the left, most of the upper bounds for the lists in the index are quite low. But if you look over here at deep impact, which is a learned model, you see that there are a lot more high impact upper bounds. And essentially those high impact upper bounds make it harder to skip documents. And so why do these learned models give high impacts? Well, they're actually able to take context into account which traditional models can't. So for example, if you consider a passage like definition of the, here the word the will be assigned a very high impact by a learned model like deep impact, because clearly in the context here the word the is actually very important. Whereas BM25 might think that because the is such a common word, at least in an English corpus, it gets a low impact. And so why this matters is essentially because these distributions are what make or break efficiency. And so, as I mentioned before, because we use these term upper bounds to make decisions on what documents need to be scored, the learned models have a harder time pruning the document space. So if you look here at the figures, you see that BM25 doesn't do very much scoring, whereas Deep Impact is scoring more documents. And if you look at it proportionally, you do a lot more work with Deep Impact. So in this work, we propose a solution that we call Guided Traversal. And so the main idea is instead of storing an index with either one or the other, so BM25 score or a learnt score, in this case Deep Impact, we store both of those scores together in a single posting, encoded with 16 bits for each impact. And then at query time, we use BM25 to guide the traversal, essentially telling us which documents we should score. And so if you look at the figure here, we have two heaps. BM25 tells us what we should score. We go and decode that posting. We then split the score into the two components, one for BM25 and one for the learn model. And that way, BM25 is telling us what to score, but we do our scoring with either BM25 or the learn model, or we can do an interpolation of both. And so results over the MS Marco passage collection suggest that this guided traversal model can improve efficiency. So we go from the gold deep impact diamond over to the left to the green triangle. And if we interpolate the learned score with BM25, we actually can improve effectiveness as well. So that's the overview of the work. I hope you found it interesting, and if you want to learn more, you can go and check out the paper, and we're happy to answer any questions you might have about the work. Thanks.